All right, a probability is a number between 0 and 1. Probability, yeah. Probability is a number between 0 and 1. We said 0 and 1, but that's not exactly true because this is for if we're in a fraction or decimal form. But if we're going to go into percent form, it's between 0% and 100%. Okay? So you will be using decimal form, you will be using fraction form, and you also will be using percent form in this unit. All right, this number tells us that the likelihood of an event occurring. Okay? An event is certain to occur if it has a probability of 1. Now, if you're in a fraction form, it's going to look like something like 1 out of 1, or 5 out of 5, or 6 out of 6, you know, something like that. And if you're in percent form, it's going to look like 100%. Okay? If an event is not going to occur, then your probability is 0. Okay? Now, if you're a fraction, your fraction is going to look like 0 out of 4, 0 out of 1, 0 out of 10, whatever. And then, or 0%. Okay? Now, granted, in a fraction form, even if you're here, it's still going to simplify to that 1. Even if you're here, it's still going to simplify to that 0. Okay, so moving on. If an event is equally likely to occur as not occur, then that probability is 1/2, or that's 0.5 in decimal form, or 50% in percent form. Okay? Like, for example, tossing a coin. Probability of a coin landing with heads up. That is a 1/2 probability, right? That's equally likely to occur or not occur. Okay? So now let's talk a little bit about the wording that we use with probability. If something is impossible, then that probability is 0. Something is certain, that probability is 1. In between there, you have a range of probabilities that are unlikely. This unlikely does not mean at exactly 0.25 you have something that's unlikely. No, it's somewhere like, you know, above 0, less than 0.5, that would be unlikely. Okay? Same with likely. Likely means it's like somewhere above 0.5, below 1 is likely. Okay? Now, 0.5, that it's possible, it's fair, right? It depends on how it's worded, whether it's only talking about the 0.5 or if there's a range around that 0.5. Now, the only numbers that for sure do not have a range are the impossible and the certain. Those only occur at 0 and at 1. Okay? Everything else is kind of like, you know, there's a range. The one thing is if you have a problem that's worded where it's asking if it's equally likely and unlikely, that's only at 0.5. So it just depends on how your problem is worded. Like, for example, if you have a problem that says, oh, something has a 98% chance of happening. Well, 98% chance, where does it fall? Somewhere like right here, really close to that 1. You're going to say, oh, yeah, that's so close to the 1. No, you can't call it certain. It's still likely. All right? So the only word you would apply to that 98% is likely or very likely. You would not call it fair or unlikely or impossible, right? Okay, so that's how the wording works out. So now, how do you actually calculate probability? Probability is the number of successes divided by the number of possibilities. So going back to that heads or tails example, if we said, what's the likelihood of a coin landing on heads? Well, your success, you won't only count that if it's landing on heads. So you only have one thing that's successful, heads, right? Possibilities, well, it's possible for it to land on heads or tails, even though the only success is heads. So the success would be one of those successes. One thing is a success, that's heads. And then possibilities, you have 2, heads and tails. So that's where the 1/2 comes from for the head probability of it landing heads. Okay. We have some other wording things, all right? So this symbol right here in probability, we will use that symbol to mean and. This symbol, we will use it to mean or in probability. You might remember those symbols from other things in math, and you might be like, oh no, that's not what it means. That means intersection. Oh no, that's not what it means. That means union. No, in probability land, that's where we are today. That's where we are right now. We mean and with that symbol. In probability land, we mean or with that symbol. Okay? Now, what does and or even mean in probability land? So, if I'm looking for the probability of a red card being drawn or a face card, okay, then I could be, anything is considered a success that's in either of those categories. So, King of Hearts, yes, that's a success because it's a red card and it happens to also be a face card, right? What about Queen of Spades? That's not a red card, but it's still a success because it's a face card. So if you're talking about or, either one of those, if either one of those conditions are met, then you have a success. All right? Now, when we're talking about and, both conditions have to be met in order for it to be considered a success. So a Queen of Spades, if you're saying it needs to be this probability and that, then Queen of Spades would not meet that because Queen of Spades is not red, right? It would need to be a face and that if it has the and thing, okay? So Queen of Hearts would meet that because it's a face card and happens to be a red card. All right, so let's do some calculations. And right now it might seem a little bit confusing, but it'll make more sense once we go through this enough times. Okay, so the calculations, first thing, there's some probabilities that were given to us. It says that a probability of a red card, it was given to us that that's 1/2. The probability of a face card, that was given to us as 3 out of 13. Now it says calculate the probability of both things being true. You draw a card and both of those having to be true. Well, when you're doing something that has and in it, it means you're going to multiply. So I take my first probability and I multiply it with my second probability. And that's where you get all of this stuff from right here. Okay? Now if you're talking about or, on the other hand, or statement means you are going to add your probabilities and then you are going to subtract your overlap. So oh gosh, I did not overlap. And you might be like, what are you talking about overlap? Well, your probability of a red card is still that 1/2, right? The probability of your face card is still that 3 out of 13 that they gave you. But in these probabilities, you actually included some numbers twice by accident, right? So all of this stuff afterwards right here, all of that stuff is not true. Cross it out. Okay? So we counted something twice by accident. What did we subtract? What did we count twice by accident? That's our overlap. Well, counted twice is my Queen of Hearts because it's a face card and it's a red card. So I have to subtract that. Okay? Counted twice is my, so any heart that's a face card. So let's see, there's Jack, Queen, King, so 3 of those. And then diamonds are also red and face cards, and they're accidentally counted twice in here. So we also have 3 of those. So overall we have 6 out of our 52 totals that we're subtracting. So where did the 52 come from? A deck of cards has 52 cards. Okay, so now we have 1/2 plus 3/13 minus 6 over 52. And some of you guys might be like, oh, fraction math. Your calculator will do it for you. All right, so put that into your calculator. And when you put that into your calculator is going to come back and it's going to tell you that you get, well, I'm going to go ahead and do it real quick. So, because I have a non-simplified fraction. So 1 divided by 2 plus 3 divided by 13 minus 6 divided by 52. Now, once you put that all in your calculator comes back and says, oh, that is 8 divided by 13. All right, now, the only problem with that answer is up here in that problem, it told us to round to the nearest hundredth, and we've got a fraction. There's no hundredth in there. So now what we got to do is we got to convert this fraction into a decimal. So we are going to go ahead and say 8 divided by 13. We already had that in our calculator, and we're going to put a little dot after that 13 to say, hey, 13 decimal, give me a decimal answer. So it gives us our answer that is 0.615 something. Okay, so when we're rounding to the nearest hundredth, we're rounding to this thing right here, okay? So if I'm rounding to that thing, I have to look at this 5, and then I ignore everything after that. So I look at that 5, is that 5 big enough to push that 1 up? Yes, it is. So I have 0.62 as my actual answer. All right, now, you might have been seeing these percents there. Some answers, some of the questions ask you to give your answer in percent form as the nearest whole percent. And in order to turn this into a percent, I am going to go ahead and multiply that by 100. This particular one did not ask me to do that, but I'm going to do it real quick anyway so you see how you do that. So 0.62 times 100, that is equal to 62. And that's where the percent comes from. Or you could just move this decimal twice over and you still get 62. Either way. All right, so if you ever have to get your answer in percent form, round to the nearest hundredth in decimal form, then multiply by 100 and you have your percent. Okay? All right. So, and is multiply, or means add, and then subtract your overlap on an or thing. On a multiply, you don't have to worry about it. Okay. Let's practice this a tiny bit more. Okay, so we have a 6-sided die and a 10-sided die. All right, so on a 6-sided die, your possible outcomes are anywhere between 1 and 6, right? 1, 2, 3, 4, 5, 6. On a 10-sided die, your possible outcomes is anything between 1 and 10, right? So you have 10 possible outcomes, 1, 2, 3, 4, 5, 6, all the way to 10. Okay, and it says that this problem says that you are going to roll a 5 on both a 6-sided die and a 10-sided die. So a 5 would be considered a success, and a 5 would be considered a success here. All right. So 5 is the only thing that's considered a success here, because it says what's the probability of rolling a 5. All right. So you have that one success right here. So one success. What are my possibilities? I have 6 possibilities because 1, 2, 3, 4, 5, or 6, right? All of those things could be possible to roll. So 6 possibilities. All right, on a 10-sided die, again, I only have that one success, only if you roll a 5. And then my possibilities this time are 10. All right, now what to do with these two things? It says, what is the probability of that and that? So I go back to my little thing right here, and it says, oh, and means I'm going to multiply. So I multiply these two. 1 out of 6 times 1 out of 10 equals. All right, I put that into my calculator, and my calculator says that is 1 out of 60. All right, the problem is, again, it told me, well, round your answer to the nearest hundredth. Now I have a fraction. Ooh. All right, so to round it to the nearest hundredth, I am going to go ahead and, in my calculator, I'm going to go ahead and say 1 divide by 60, and then I'm going to put a dot after that 60, and I get 0.016667. All right, nearest hundredth is right here. And so if I'm looking to round to the nearest hundredth, I'm looking at one thing after, and I'm ignoring everything there. So that is equal to 0.02, because that 6 is big enough to round that 1 up. All right, so that's your answer to the nearest hundredth for P of 5 on a 6-sided die plus P of, times P of 5 on a 10-sided die. Okay. Moving on. What is the probability that you roll a 5 on a 6-sided die or you roll a 5 on a 10-sided die? So it looks identical to the previous problem. The only thing that's different is here it had an and here has an or. So, or we said we're going to get the probability of the first thing, that, plus the probability of the second thing, that, minus any overlap. Well, I have my 6-sided die in this hand, and I have my 10-sided die in this hand. There is no overlap. They're two separate die, right? So no overlap in this case. So in this case, 1 out of 6 plus 1 out of 10. We'll do that in my calculator. 1 divided by 6 plus 1 divided by 10. And my calculator says it is 4 divided by 15. Ugh, problem again, nearest hundredth. So I'm going to go ahead and say 4 divided by 15 dot in my calculator. And my calculator says 0.27. Well, it says 0.26667. It rounds to 0.27 if you're rounding to the nearest hundredth. Okay, so moving on. I have a deck of cards, but this whole deck of cards is just my 13 clubs. Okay, so my 13 clubs, how many of those 13 clubs are face cards? I have 1, 2, 3 face cards. What's the probability of drawing a face card? Well, 3 face cards, and there's 13 cards total. So 3 out of 13 is my probability of drawing a face card. What about an ace? Well, there's only 1 ace here. So 1 out of still 13 cards. Okay? What about a club? I don't see any clubs, do you? Nope. So 0 out of 13. What about, oh, actually, I take that back. Those are clubs. Those are all clubs. All right, so we have 13 out of 13. All 13 cards are clubs. What about a spade? There are no spades here. So 0 out of 13 spades. All right, so now the only thing is, it didn't tell me I have to round or put my stuff into the nearest hundredth or anything like that, so I can leave it like this, except for, if I'm going to put my answer as a fraction like that, I do want to go ahead and simplify. So when I put 13 divided by 13 in the calculator, you get 1. When you put 0 divided by 13 in the calculator, you get 0. All of these, when you put them in your calculator, they're going to tell you it's the same thing. 3 divided by 13, your calculator is going to say 3 divided by 13. So we're good. That's simplified enough. All right. We have this spinner over here. What is the probability that that spinner lands on a 5? Boo, there's no 5, right? So no 5, 0. It cannot happen, right? What is the probability that the spinner lands on a 1? Well, there's just a 1, 1, and there is 4 possibilities, so 1 out of 4. What is the probability that it lands on an odd number? Well, I see 2 odd numbers right here, the 1 and the 3. So 2 odds out of 4 possibilities, and that can be simplified to 1 out of 2. Okay. What about the probability that it lands on something less than 6? All of these are less than 6, so all of them 1, right? Or 4 out of 4, which turns into 1, right? What about that it lands on an even number? Well, we have this even and this even, so 2 even numbers out of 4 possibilities. That simplifies into 1/2. All right, and the probability that it lands on a number greater than 6, nothing here is greater than 6, so 0. Okay, so that's how you do that. All right, you have a 6-sided die. What is the probability that you roll a 1 on a 6-sided die? Well, 1, there's only a single 1 on a 6-sided die, but there's 6 total numbers. There's only a single 2 on a 6-sided die, but there's 6 numbers. There's only a single 3 on a 6-sided die, but there is 6 numbers. There's only a single 4, right? But 6 numbers. I said the number 4, I was going to put 4 there. All right, so you get it. All of these numbers are only on the 6-sided die one time. Okay, so there's that. And now the problem is we need to go ahead and make that to the nearest hundredth, right? This one told us specifically to do that, so we have to do that. So if I do on my calculator 1 divided by 6, I put a dot after it, then I get 0.1667. So that is equal to 0.17 if I'm rounding to the nearest hundredth, which means one place after, like here, 2 places, because 100 has 2 zeros, so you're going to go 2 places after the decimal. All right, so all of these are 0.17 when you round to the nearest hundredth. Okay, moving on. What's the probability that you will get a heads when you toss a quarter? Well, one thing would be successful, heads, and you have 2 possibilities. So 1 out of 2, and when you make that into decimal form, it's 0.5. Or some of you guys might be like, oh, there's nothing in the 100th place. If there's, you can put a 0. On Canvas, do it like this. Okay? Don't actually do this. Put it just like this on Canvas. Okay? Even though these are technically the same thing. All right. You roll a fair 6-sided die. What's the probability that the die lands on an even number or a number less than 3? All right, for this one, I do actually want to write down the possibilities, because with OR problems, it's actually easier to do it when you just write down all of your possibilities. So, even. The possibilities for even are 2, 4, and 6. Those are the possible outcomes, right, on a 6-sided die. Now, we said the other one was less than 3, so the possibilities for less than 3 is 1 and 2, right? So now, when I'm looking at even or less than 3, combine them. So even or less than 3. So I'm just listing all the things that were listed here. We had 2, 4, 6 at the top. We had 1 at the bottom. And then, look, 2 was listed again. That was the overlap that we were not going to write again. It's already there. That's why we have to subtract overlap on an OR question. But if I'm listing out my possibilities, as long as I make sure that I do not write this 2 twice down here, I've already taken care of subtracting the overhead. It's gone, right? So overall, even or less than 3, we have 4 possible things. We have 6 different, because 1, 2, 3, 4, right? And it's a 6-sided die, so there's 6 different things there, which is now 0.67 if we have to round it to the nearest hundredth. Okay, now some of you guys might not like it this way, so the other way to do this, all right, same problem, other way to do it is even. You're still going to be like, oh, 2, 4, 6, so that's 3 out of 6. Less than 3, you're still going to think, oh yeah, that's 2 out of 6. Then subtract your overlap, and the reason why I don't like doing it this way is it's a little bit harder for you to picture where's the overlap. But this way, it's really easy to be like, oh, 2, just make sure not to write it twice. But 2, there was 1 overlap, 1 number that overlapped, so we subtract that 1 number that overlapped. And we still end up with 4 out of 6, which is equal to 0.67. So either way works. I say go with this way. It's way easier. You're listing out your possibilities and then just counting. All right. Because here, 3 out of 6 plus 2 out of 6 minus 1 out of 6, you still get 4 out of 6. All right, moving on. Last problem. This problem gets tricky, a little bit tricky. All right. So we have some shirts, and for this particular problem, I think it's best if we create a table, okay? Because there's just so many things going on. All right. So we have red shirts, we have yellow shirts, we have shirts that fit, and we have shirts that don't fit. They're big. Okay, and then we have our totals. Let me move that total here over a little bit. Okay. All right, overall red, we have 5 red shirts. Overall yellow, we have 3 yellow shirts. Now, there's a problem. 5 red, 3 yellow, but you're telling me there's 13 shirts total, which means that there's a section missing here of other colors. So if there's 5 and 3, but you have 13 total, well, that's 8. Oh, there's 5 other shirts that if you add them all together, now we have the 13, right? So there was some information missing. That's why we had to create the other column. This other column is not always going to be there. It's just, in this case, it made sense because they told us the overall total was 13, and these two did not add up to that overall total, okay? So I'm going to create another total column here. All right. Now it says that 1 of my red shirts and 2 of my yellow shirts fit well. So 1 of my red shirts fit, 2 of my yellow shirt fits. And then it says none of the other shirts fit well. It says everything else is too big. So none there. So now I have to fill in these gaps. If there's 1 red shirt that fits and there's 5 total red shirts, that means there's 4 that are too big, right? Because they have to add up to this 5. All right, this means that there's 1 yellow that's too big, because overall we have to add up to 3 total yellows. 5 other colors that are too big. Okay, so now let's add up this way. 1 plus 2 is 3, and 4 plus 1 plus 5 is 10. Do things add up this way to get the 13? Yes. 3 plus 10 is 13. Do things add up this way to get the 13? Yes. All right, so our table makes sense. Now, we went through all that trouble to make the table. These things right here on the outside, these are all the totals. All right, and these are the individual events. Okay. We went through all that trouble to make the table because it makes it easier to see things. All right. What is the probability that a shirt is red or fits well? Or means I'm going to add and then I'm going to subtract the overlap. So P of red, let's see, we have 5 reds, we have 13 total. Probability of fit, we have 3 fit, we have 13 total. Now I have to subtract the overlap. Red and fit well. Well, red and fit well is that 1 right here. This 1 is red and fits well. We accidentally counted that twice. So 1 and fits well, it's 1 out of 13. Okay, so now overall we have 7 out of 13 that work this way when you add up your probabilities. All right, so 7 out of 13, we have to round that to the nearest 10th again, not 10th, nearest 100th. So 7 divided by 13 dot, and then you get 0.54. Okay. All right, moving on. This next one gets way easier. What is the probability that a shirt is yellow and fits well? Well, let's see. Yellow fits well. We've got 2. 2 shirts are yellow and fit well. 2 out of 13. That's your answer. You don't have to think beyond that. But some of you might be like, but you told me and means you're going to multiply, right? Well, if you want to see the actual multiplication, you don't have to, but if you want to see the multiplication, this is where the 2 out of 13 comes from, all right? What is the probability that it's yellow? Yellow, we've got 3 out of 13 that are yellow. What is the probability that it's that it's yellow and happens to fit, like, what's the probability that it fits well given that it's yellow? All right, so if it fits well given that it's yellow, there's 2 out of 3 that fit well given that they're yellow. So that's where you get the yellow and fits well from. When you multiply this, then you end up with 2 out of 13. Do you need to know this? No, you need to be able to write down the table and identify on the table that 2 out of 13 are yellow and fit well. Okay, so now that 2 out of 13, we do still need to go ahead and put that in decimal form. So 2 divided by 13 dot, and it gives you 0.15. All right, that's how you do that. Good luck with everything.